So for trigonometry, it's just a fancy way of asking us to find a fraction or a ratio from our triangle. And we have this little mnemonic device over here called SOHCAHTOA to help us remember that. So they're going to ask us a question like find the sine, and it's S-I-N, but the long word is S-I-N-E. So the sine of angle A. Now we remember this, or I remember it, by doing the opposite side over the hypotenuse. So if angle A was here in our triangle, we would take our opposite side and put it over the hypotenuse. So let's actually try this out over here for sine of E. So I go to E in my diagram, and at first I look for the side opposite of E. Turn off my tools here. So side opposite is 24. Then I need the hypotenuse. And in this triangle, in any triangle, our hypotenuse is always across from the 90 degrees. So for this one, 24 over 25. For sine D, I'm going to go to the top angle. So here's angle D. And then I have to go relative to that. So our opposite side for angle D is 7. But for sine, the hypotenuse is always in the bottom. So 7 over 25. All right, our next ratio is cosine. And that's our ca part of SOHCAHTOA. So over here, this is our cosine. And it's spelled co, like the prefix. So that's with the sine function up top. And this can be found by using the adjacent side over the hypotenuse. So notice I abbreviated, and we abbreviate cosine to COS. And we'll try it out in this triangle again. So cosine of angle E. So I'm going to go to angle E. And it might even be easier to do the hypotenuse first. My denominator is the hypotenuse. And then I need the adjacent side. So since I already used the hypotenuse for this one, my adjacent side is this guy, 7. That's right next door. So that would be adjacent to angle E. So 7 over 25. Now, if I change my angle, like this one, cosine of angle D up top, then I'm going to have a new adjacent side. But my hypotenuse is still the same, so 25. My adjacent side to angle D is the one right next door that it's touching, right? We don't have to go across. It's the side that opens up with the hypotenuse. So cosine of D would be 24 over 25. Last of our trig functions is called the tangent. We remember that by TOA again. So I'm saying SOHCAHTOA. All right, so just a silly way to remember this. And tangent is those last two sides of a triangle, opposite over adjacent. So we use the abbreviation tan, and that's the opposite side of our triangle over the adjacent side. Now let me throw into these pictures, I forgot our cosine. We would need our adjacent right next door over the hypotenuse. And I'll call them all angle A. And tan is opposite over adjacent. So let's go back to this triangle example over here. So for tangent, we don't need the hypotenuse. I'm actually going to erase that too. Let's start with tangent of E. So angle E, first thing I need for tangent, TOA, is opposite. So that's 24. Then I need the adjacent side. I should have left my label. The hypotenuse is here always. We don't need that guy. So my adjacent side would be 7. Same thing for tangent of D up top. I need first my opposite side, which is 7, then my now adjacent side, which is 24.